Okay, so this is the intro to these topics, and we'll go into detail today and tomorrow with some of them. Perpendicular bisector of a triangle. What two things need to happen for a perpendicular bisector? What makes it perpendicular? A right angle, good. And what makes it a bisector? Divides equally in half, good. And sometimes we say that by it goes to the midpoint, which means that's right in the middle, it cuts it in half. So perpendicular bisector, a line or segment that passes through the midpoint of a side and is perpendicular to that side, or it forms a right angle at the midpoint. So they both have to happen together. All right, so for example, it could go right here. If this is the midpoint, these two halves are equal to each other. Then a perpendicular bisector would come right down the middle at a right angle. It does not have to go through the vertex of the other side. The other special names we had do. Perpendicular bisector is the only one that doesn't have to go through a vertex. Okay, I drew 3 triangles there, so you could see it doesn't have to be only on the bottom. You could have a midpoint over here, and then you could have a perpendicular bisector going through it at a right angle. And you could do it at any of the sides. All you need to do is have a midpoint and a line that goes through that midpoint at a right angle. Okay, what's the angle bisector going to do? Bisector is going to cut in half. Where? At the angle or one of the vertices. Good, has to be at the corner. So it bisects, it cuts in half an angle. So you can either have this angle right here that gets cut in half, or you can have this angle that gets cut in half. And notice, it doesn't mean that the other side is getting cut in half. That only happens in special cases. Or this one right here is getting cut in half. You can have an angle bisector at any of the angles of a triangle. Median, where's the median gonna hit at the line? The middle, the midpoint, good. Segment that connects a vertex of a triangle to the midpoint of the side opposite from there. So it connects a vertex of a triangle to the midpoint of the opposite side. So this one does have to go through one of the vertices. So your midpoint could be right here. That could be a midpoint because it cuts that line in half. But a median would have to connect from that midpoint to the opposite vertex. You could have your midpoint on this side. And in order to be a median, it has to connect from that midpoint to the opposite vertex. And you can have a midpoint on this side. Notice it does not have to go at a right angle. It has to angle itself over to where the other vertex is. And the last one, altitude. What's special about an altitude? It has to have a right angle, good. It has to be perpendicular. And it has to go through the other vertex. It has to go all the way across a triangle. So a segment that connects a vertex, one of the angles, a vertex of a triangle to the side opposite that vertex, and is also perpendicular to that side, meaning there's a right angle. All right, so here's your vertex. You don't draw it to the middle, you draw it straight to the other side to form a right angle. Here's a vertex. You draw it straight from that corner and you draw it to the other side, forming a right angle. It doesn't have to cut anything in half. And then we've got this one. Here's a vertex, draw to the other side, forming a right angle. Oops. Okay, so which is the only one that does not have to go through one of the vertices? Perpendicular bisector, good. That's the only one that's even possible to not go through the vertex. Okay, turn the back side. Let's do this really quick. This is a review from Friday. If you got confused on any of that homework from Friday, please see me and I'll help you get unconfused so you can get your score up on that one. All right, there's only one diagram, but there's 5 different pieces of information here. So use the diagram shown and the given information to decide if AD is perpendicular bisector, an angle bisector, or a median. So we're talking about AD right here. That's the one that they're asking about. So we have to look at the different given informations. If DB was equal to DC, if that was the case, and that's all you know, what name could you give this? Just like on your work from Friday. Median. Excellent. It goes to a side that is cut in half, and it goes through the vertex and nothing else. All right, number 2. What if all you knew was that BAD was equal to CAD? What's the name you could call that? Angle bisector. Good. That green line is an angle bisector. It bisected angle A in half. What if all you know is that DB is congruent to DC and that AD is perpendicular to BC? What name would you give that one? Perpendicular bisector. It's got the right angle and it cuts it in half. It does both at the same place. The same side has to have the right angle and be cut in half. And then if all you know is that AD is perpendicular to BC, what name is that? The altitude. That's right. Another name for height. Even though it's not going to the bottom, it's still going to one of the sides at a right angle, so it still counts. And then it says the triangle BAD was congruent to triangle CAD. By CP/CTC, if all these parts were equal, right here, all these angles were equal, what names could you give it? Is it a perpendicular bisector? It's all of them, yep. Perpendicular bisector, it's an angle bisector, it's a median because that side is in half, and it's also an altitude. If the two triangles are equal to each other, those would have to be right angles. So all of the above, all of them. All right, I'm going to do one with you from the bottom, and then you're going to try some on your own. Name a line or segment that represents the following. You had this on your homework, but some of you might not have gotten that far, and you're going to work to getting there. But if I'm looking for a median, what am I looking for? A midpoint. Which segment do you see has two halves that are equal to each other? Yep, right here. This side right here is the one that got cut in half. So that means D is a midpoint. These two halves are equal. So where does the median go to? From D to what letter? No, those are the two halves. A median has to go across the triangle to the other vertex. So DA would be the median. DA. Has to have the midpoint and it has to have the other vertex. Okay, try 7, 8, and 9 on your own. Okay, angle bisector. Where's the angle that you see cut in half? What letter? Okay, good. Let me say the question one more time. What angle do you see that got bisected, that cut in half? Just one letter. Angle B. Good. I wanted everyone else to see it too. Angle B here is the one that got cut in half. So the bisector goes from B to the other side of the triangle. So that would be BF or FB. Got to find the characteristic first and then go to the other side of the triangle. The altitude. For altitude, you're looking for a right angle. There's two places where there's a right angle, at E and at H. Which one would constitute an altitude, though? At the E. Because the altitude does have to go through the vertex of the other side. Perpendicular bisector doesn't, but altitude does. And for perpendicular bisector, I wrote none. Because they didn't say here anywhere indicating that this half would be equal to this half. You have to have that. It could be perpendicular, but it also has to be bisecting the same side. Okay, so for your homework tonight, you're going to be focusing on medians and altitudes, I think. Medians and altitudes. So turn over to 4-4. That 4-2 is a little bit more confusing. I'm going to save that for tomorrow. But for today, turn over to 4-4. All right, quickly, it's a lot of the repetitious stuff, but up here, number 4, write medians and altitudes. Everything in your homework is going to represent medians or altitudes for today. The median goes from one vertex of the triangle to the midpoint of the other side. Please look at it a different way now. Over on the right, name for me 3 medians. Start where the midpoint is, like the letter L. And name that median for me. Where does it go? L to what? LB. So LB is one median. What's another median? XC. Good. X is a midpoint and it goes across to C. And what's another median? Good. M is the midpoint and it goes to A. You could also say MA. You can change those 2 letters. An altitude is a segment that runs from one vertex perpendicular to the line on the opposite side, making a right angle. So the 3 altitudes are find the right angle and then count it going across the triangle. So we would start at N, here's a right angle, N what? NS. You said QT. Good. T is the altitude or the right angle, and it goes up to Q. And the last one, the right angle is at U, and it goes to R. Good. UR. On your own, do number 1, 2. There's really not much more for you to learn. There's just some practice here. I just have to show you one more thing on the back side. So go ahead and try this page on your own, number 1 through 9. Actually, you know what? Try 1 through 5. No, I'm going to say 1 through 6 because things change on number 7. So do 1 through 6. Okay, number 1, what'd you get? Altitude. Good job. It's not neither. It is altitude. It is not a median because 3 and 3.2 don't match, but it does have a right angle. What'd you say for number 2? Median. Goes to the middle. And number 3? And number 4? Neither. What would it be? Angle bisector. Good. So for number 5, they're talking about this triangle right here. Let me get you focused on the right parts because for number 7 it changes. They want you to deal with triangle DEF. So looking at that one only, find a median. What median would you say? LD. Good. Here's a middle. Here's a midpoint. The 2 sides are cut in half and it goes to D. LD. What would be an altitude for that one? FK I'm hearing. K is where the right angle is. And it goes over to F. Good. FK. Now, what's different about number 7, though? Not that same triangle. Good. They're talking about the triangle that goes from E to H to F. Those are the only parts you're allowed to look at now. And they want a median. Well, the midpoint is still L, but where does it go from there now? To H. Good. So as the triangle changes, your letters have to change. Number 8, they change the triangle again. So now you're looking at the triangle from H to E to K. H to E to K, that triangle right there. On that tiny little part, they want to know what an altitude would be. Where's the right angle? Good. You can either say KH, that's true, or you could also say KE, that's true. There's nothing saying which vertex it has to go to. It just has to go to one of the other vertices. So either one would be true, KH or KE. KH or KE. All right, and lastly, what's the best description of AB? Number 9, altitude. That one has a right angle and nothing else. And it does go through the other vertex. Okay, now all of this comes from review from Friday. All these definitions, you've got to know them really well because then you're going to start seeing problems like the next page. We'll skip the top for now because you're pretty good with that. But let's look at where it says to solve for X. Where the problem changes up a little bit, you have to be aware of these. These will be on your little mini test. We're not taking a full test on this chapter because we're going to do it really fast. If you'll notice, I said there's a mini test next week. I'm not sure if it's Wednesday or Thursday, but it'll be sometime of next week. All right, so number 4, look at this question. Tell me what you know. Yep, we know there's an altitude. What does that mean? 90 degrees. So let's go to AD and make a 90-degree mark. 90 degrees. That's key. None of these other numbers matter right now. All that matters is that right angle. So what can I say? 90 equals what? That's it. That's perfect. Okay, so the word clue is going to tell you what equation to make to be able to solve for it. So 4x plus 10 equals 90. I'm going to subtract 10 from both sides. I'm going to say 80 equals 4x and x equals 20. And I'm not going to stop there because I'm going to go back and read the question. What do they want me to find? AC. So all I have to do is go back to where AC is right here and plug it in. X is 20, so it's going to be 3 times 20 plus 2, 60 plus 2, 62 is the final answer. Okay, so for the rest of the chapter, you're going to see problems like these thrown in, and you have to know the rule in order to find the right equation. Number 5, find AC. You want to find this one if AD is a median. On your own right now, don't solve it. But on your own, think about that word median and think about what it means and what equation you can come up with. Median means it's going to the midpoint of the other side. Don't solve it yet. I want to make sure you saw or wrote the right one. But look at that picture and think about AD being a median. That means that there's a midpoint somewhere. Something got cut in half equally. Where do you see a midpoint? No. It goes to the midpoint. Draw to the midpoint. Right there. So what two things are equal then? All right. What two pieces are equal? Good. If AD is a median, that means that's the midpoint right there. So 1/2 equals the other half. 5x plus 5 equals 7x minus 3. Subtracting 5x from both sides, we get 2x. Adding 3 to both sides, we get 8. And x equals 4. All right, that's not the answer. Find AC. $16. 4 plus 12, 16. Okay, so from now on, you're going to be using the clues that you know and using that in a problem to solve for X, find the missing piece, all of that stuff. All right, before you start in on your work, I'm going to give you lots of time. Go ahead and finish up number 6. But this time, they're not asking for a name. This time, they're asking for the value or the length of each segment. So I'll start you off. AH. What would AH be? 12. It's the same as HB because they have the equal marks there. So finish up that problem and then get your computer. We're going to go to homework in Socrative. All right, so let's check it quickly, then you can start. Number 6, what did you get? 24 for AB? 24, 5, 10. Good. If there's any questions, please let me know.